Hello and welcome back to the tutorial or walkthrough through MDN's A Reintroduction to JavaScript. My name is Caleb Arend and I'll be walking through this tutorial with you. This is also acting as my vlog post for class 12 of the JavaScript 411 class held through the Austin Coding Academy Coding Bootcamp. So without further ado, let's pick up where we left off. We started with the top of the article, a reintroduction to JavaScript, and the link is in the show notes or the description below if you'd like to follow along. And we left off looking at recursive functions, so that's where we're going to pick up right now. And it says JavaScript allows you to call functions recursively. This is particularly useful for dealing with tree structures, such as those found in the browser DOM. Before continuing, I want to note that I did not create any of this content, and I'm not claiming that I have created any of it. This is all MDN's content, and I give full credit to their creation and their teams for all of this content. I'm simply doing a walkthrough of what they have freely available on the internet. Now, continuing on, recursive functions. So this function has the function keyword with the name count chars and passes in elm. And it says that if elm.nodeType is equivalent to 3, then return elm.nodeValue.length. But if that code does not run and it does not return, then it's going to set the count equal to 0. It's going to create a variable with I and in a for loop and set it equal to 0. It's going to then access the child there, and it's going to evaluate whether the child is equal to the Elm child nodes set at I, or I'm sorry, it's going to set the child equal to Elm.child nodes at index I, and then it's going to increase the variable I with the counter, and then it's going to set the count equal to what the count was previously plus the count chars of child. And so it's going to call the function itself, passing in, instead of elm the first time, now it's going to pass in the child. So it's going to go into the first function call. It's going to go down to this code. It's going to set the count equal to the count chars of child. It's going to call the next function recursion with the child. It's going to run through this code, and instead it's going to look at the child. It's going to increase the count, and it's going to keep running until either the elm.nodeValue.length or the elm.nodeType is equal to 3, and then it's going to return that node value length, or it's going to return the count. This highlights a potential problem with anonymous functions. How do you call them recursively if they don't have a name? And so we just went over anonymous functions in the previous section here, and that's where JavaScript allows you to create a function without giving it a name. It even has immediately invoked function expressions, which allow you to create a function and immediately invoke them without giving them a name. This is bringing up the problem, how do you use functions recursively if they don't have a name to call them with? And so they can do that by what is shown below here with this code example. And it says that it's declaring a variable chars in body, and it's setting it equal to a first parenthesis, then using the function keyword, and then setting the function name to counter, and then you passing in elm and evaluating the node type, and then going through this code again. But this time it's immediately invoking this function where the IIFE, or the immediately invoked function expression, is calling the counter elm and then getting down here and calling the counter child as well. And so this function that's calling the counter function is not being called itself by any function name. It's just immediately invoking this code in this process, and then calling the counter at the bottom of the code here inside the for loop. The name provided to a function expression as above is only available to the function's own scope. This allows more optimizations to be done by the engine and results in more readable code. The name also shows up in the debugger and some stack traces, which can save you time when debugging. What that means is that this function does not have a name that's available in the global scope of all of the rest of the document or all the rest of your code, which means that if you have multiple functions or things that have very similar variable names, you don't have to worry about any of those variable names getting mixed up, because all the variable names like the counter passed in Elm or counter passed in child are only available inside this block level scope of this immediately invoked function expression. Note that JavaScript functions are themselves objects, like everything else in JavaScript, and you can add or change properties on them, just like we've seen earlier in the objects section. Now getting on to custom objects. Note, the content in this section does not cover modern JavaScript features, including support for classes. For a more detailed discussion of object-oriented programming in JavaScript, see Introducing JavaScript Objects and Inheritance and the Prototype Chain. If you want to look up the classes syntax and stuff like that, you can look that up as well. I don't believe they go very much into detail on that in this document. So let's consider a person object with first and last name fields. There are two ways in which the name might be displayed, as first last or as last first. Using the functions and objects that we've discussed previously, we could display the data like this. Function make person first, last, then return first, and then last, set as last. And then there's another one, person full name function, and passing in the person and returns the person.first and returns the person.last. This first function makes the person object. The second function here prints out or returns the first name, then the last name. And then the second or the third function here, person full name reversed, passes in the person, then returns the last name of the person, and then returns the first name of the person. The constant variable s is set to the function make person, passing in the values first name Simon and last name Willison. Calling the person full name after passing in the s object prints out their first name Simon and their last name Willison. But calling the person full name reversed function and passing in that same information prints out their last name first, Willison, and then their first name. This works, but it's pretty ugly. You end up with dozens of functions in your global namespace. What we really need is a way to attach a function to an object. Since functions are objects, this is easy. So this function make person creates a person object using the first name and last name parameters. It returns an object with first key set to their first name, last key set to their last name, and then a function set to the full name key that returns this dot first and then this dot last. And then a second function set to the full name reversed key, which returns this dot last and then this dot first, all inside that object. So as the variable const s is made with make person function, which passes in their first name and then their last name, if you call that object s and then call the full name method on that object, it returns the first name and the last name. If the full name reversed method is called on that object, it returns that object's last name and then it's their first name. Note on the this keyword. Used inside a function, this refers to the current object. What that actually means is specified by the way in which you called that function. If you called it using dot notation or bracket notation on an object, that object becomes this. If dot notation wasn't used for the call, this refers to the global object. Note that this is a frequent cause of mistakes. So if they use the example, const s equals make person, passing in first name Simon, last name Willison, and then they try to set a constant variable of full name equal to s dot full name, and then they try to call the full name method, then they will get undefined, since when they had passed in that full name key, they had set it equal to a function that returned this dot first and this dot last. But then they tried to change the full name variable and then set that equal to the function that was stored inside the S object, then they tried to use full name, and instead of using S dot full name, accessing the object and then the method inside it, they just tried to call the function from the global scope. It returned undefined because it could not access the first name and the last name keys that were inside the object S. When we call full name alone without using S, accessing the object first, and then the full name method, this is bound to the global object, and it's not bound to S. Since there are no global variables called first or last, we get undefined for each one. We can take advantage of this keyword to improve our makePerson function. So they call the function person, pass in first and last, set this dot first equal to first, this dot last equal to last, creating the first and the last keys set to the values of first and last that were passed in, and then set the this dot full name, creating the full name key, and then set to the value of the function that returns this dot first and this dot last, and then creating the full name reversed key with this dot full name reversed, and setting the value of that key equal to the function that returns this dot last and then this dot first. And then they can call the constant keyword with the S variable and set that equal to a new person with the first name of Simon and the last name of Willison. We have introduced another keyword, new. New is strongly related to this. It creates a brand new empty object and then calls the function specified, with this set to that new object. Notice, though, that the function specified with this does not return a value, but merely modifies the this object. It's new that returns the this object to the calling site. Functions that are designed to be called by new are called constructor functions. Common practice is to capitalize these functions as a reminder to call them with new. The improved function still has the same pitfall with calling full name with the parentheses alone, trying to invoke a function in global scope when it doesn't have access to the variables that that function needs to be able to run properly. Our person objects are getting better, but there are still some ugly edges to them. Every time we create a person object, we are creating two brand new function objects within it. Wouldn't it be better if this code was shared? And so they're creating now a function of person name full, or person full name, which returns this dot first and this dot last, a function of person full name reversed, which returns this dot last and this dot first, and then a function of person, which takes in a first and a last, sets first equal to first, and sets last key equal to last, and then sets the full name key equal to person full name, and then sets the full name reversed key equal to person full name reversed. That's better. We are creating the method functions only once and assigning them references to them inside the constructor. Could we do any better than that? And the answer is yes. So why don't we take a look at this with some live examples as well. So let's delete this. Let's post this in here and we'll clear this out. So this, we have access to person full name. We have access to person full name reversed. And we have access to person here. So let's call new person, give them the name of Bob as the first argument, and then the second name of Smith as the second argument. And now let's call full name. And let's see what runs here. Full name is not defined. So we have, that's right, person full name. Person full name. Run again, and it returns, but it doesn't print out to the console. So let's console.log this person full name. See if there we still get undefined and undefined. But if we set const a person1 equal to new person with the Bob and Smith, they have access to this dot full name and this dot full name reversed. And so if we run console.log with person1 dot full name, and then on a new line, we also run full name reversed on person1. Now we should get Bob Smith and Smith Bob. That's better. We're creating the method functions only once and assigning references to them inside the constructor. Can we do any better than that? We just read that, but now can we do better than that? And the answer is yes. And so they create the function with the person, which sets their first name equal to first and their last name equal to last. And then it uses the prototype keyword here. What is that doing? And it says person.prototype is an object shared by all instances of person. It forms part of a lookup chain that has a special name, prototype chain. Anytime you attempt to access a property of person that isn't set, JavaScript will check person.prototype to see if that property exists there instead. As a result, anything assigned to person.prototype becomes available to all instances of that constructor via this object. This is an incredibly powerful tool. JavaScript lets you modify something's prototype at any time in your program, which means you can add extra methods to existing objects at runtime. That's incredibly powerful. Let's look at this in this improved code here. As we're replacing this code, we create a person, and we haven't created a new person here. Let's create one. Person1, same variable name we used before, and set to new person with the name Bob for first name and Smith for last name. And let's see, we have full name and full name reversed set to those values. So let's run it again, and it should work, and it does. Bob Smith and Smith Bob. So they created here an example of the variable s is set to a new person with Simon Willison, and it calls s.firstname caps, but there's a type error since it's not a function. It's that first name caps has not been defined yet. And so they create on the person prototype chain, they create the method first name caps and set it equal to the function of return this dot first to uppercase, and then they call it again and it runs. And so let's try that, just copying this code here, and then we'll run person1 dot first name caps to make sure it works as well. Move this down here, copy, paste, and we'll say instead of person1 full name reversed, we'll say person1 dot first name caps. Run that, and it capitalizes their first name at Bob there. Interestingly, you can also add things to the prototype of built-in JavaScript objects. Let's add a method to string that returns that string in reverse. So we have a string with set to the variable s, and then it is trying to reverse that string with the reversed method, but it's saying that that's not defined yet. So they create a method called reversed on the string prototype chain, and then they set it equal to the function that takes in a variable letter. Well, it creates a variable set to an empty string, and then for each I that they create and set it equal to this dot length minus 1, they evaluate if I is greater than or equal to 0, and then they decrement it. And so they set R equal to whatever R is currently plus this, meaning whatever string prototype it is being used on, at the index of I, which starts at the last index, since it's it goes to the length, which is one more than the last index, subtracts that one, so it starts at the last index, and then decreases by one until it reaches 0. And then it returns the string that has been reversed. So then they call reversed on S, which is Simon, and they get out this namus string at the bottom. Our new method even works on string literals. So if they use this can now be reversed, dot reversed, it reverses that entire string there. So let's practice this. Let's take all of this code here, and let's grab all of our code here. We'll delete it. We'll paste this in, and it takes this in, and now we'll console.log s.reversed. Go to our console, clear, and then run node test.js, but there's a type error because we're trying to call s.reversed before it's been defined. So now let's run it again, and now it works. If we copy this and try to console.log it to the screen, oops, hit the wrong thing. There we go. We'll have to delete this and then run it again. Now it reverses that string literal. As mentioned before, the prototype forms part of a chain. The root of that chain is object.prototype, whose methods include toString. It is this method that is called when you try to represent an object as a string. This is useful for debugging our person objects. So they create an object, or they create a variable set to that's named S and set equal to new person with the name of Simon Willison. And then they run s.toString, and it should print out object. But then they set person.prototype.toString equal to the function return the string of the string literal with the string starting with person and then a colon, and then accessing that literal notation that they can use, and they set this to this dot full name, and then they exit out of that string literal notation and then get back into the regular string, and then that should print out s.toString, and instead of returning object, it now prints out person Simon Willison. So if we copy all of this code, we should be able to practice this as well. So move this code, post this in here, and then we're going to console.log, and we'll print this out here. We'll print the top one out as well. Clear the screen, run. That's right, because person is not defined. My apologies. So we got to come back up to here. We got to grab the person code up here. And before we're trying to create a new person, we have to create the function for a new person. And now person.toString, this dot full name is not a function. Okay, because we need this code here as well. So post that in here, run again, and the first line prints out object, but after we make an alteration to the toString method that's on the different person objects, and then we call toString, then it prints out this dot full name or person with the object literal, string literal, this dot full name in there, and then that's what it prints out. Person.prototype is an object shared by all instances of person. It forms part of a lookup chain. We just read that, didn't we? Yes, we did. We were down here past string literals, and where we just altered the toString method that was on those literals now, or on those object prototypes. Remember how average.apply had a null first argument? We can revisit that now. The first argument to apply is the object that should be treated as this. For example, here's a trivial implementation of new. And so we have a function named trivial new. It takes in a constructor and it takes in the arguments. And so it has const of a variable O is equal to an empty object. And then it has constructor.apply and sets that O of the empty object and then the args that are passed in, and it returns O. This isn't an exact replica of new, as it doesn't set up the prototype chain. It would be difficult to illustrate. This is not something you use very often, but it's useful to know about. In this snippet, args, including the ellipsis, is called the rest arguments, as the name implies. This contains the rest of the arguments. So if we set a variable Bill equal to trivial new and then pass in a person and then pass in the name William and the name Orange, is therefore almost equivalent to setting the Bill variable equal to new person William Orange. Apply has a sister function named call, which again lets you see this, but takes an expanded argument list as opposed to an array. So a function with last name caps as the name of the function, which returns this dot last to uppercase. And if they create a new person set to the variable S with Simon Willison, and then call last name caps and dot call with passing in S, it's the same as saying S dot last name caps is equal to last name caps, or and then calling S dot last name caps, which sets the object's key last name caps equal to the function last name caps and then calls it. But that'd be the same. These two are the same. This just does in one line what this down here is doing in 2 lines, and still calls out and prints out the last name of the person in capitals. Inner functions. JavaScript function declarations are allowed inside other functions. We've seen this once before with an earlier makePerson function. An important detail of nested functions in JavaScript is that they can access variables in their parent function's scope. So this first parent function is created and has a variable set to a and equal to 1, and then has a nested function called nestedfunc, and creates a variable v and sets it equal to 4. And this nested function has access to its variable as well as its parent's variable, and it can return a plus b. And then the parent function can return the nested function, calling nested function, and it returns 5 because it adds both its parent's variable that it has access to as well as its own variable that it has access to. This provides a great deal of utility in writing more maintainable code. If a called function relies on 1 or 2 other functions that are not useful to any other part of your code, you can nest those utility functions inside it. This keeps the number of functions that are in the global scope down, which is always a good thing. This is also a great counter to the lure of global variables. When writing complex code, it is often tempting to use global variables to share values between multiple functions, which lead to code that is hard to maintain. Nested functions can share variables in their parent, so you can use that mechanism to couple functions together when it makes sense without polluting your global namespace. Local globals, if you like. This technique should be used with caution, but it's a useful ability to have. Our next section is called closures, and this is the last section of this reintroduction to JavaScript article. And closures, it says, this leads us to one of the most powerful abstractions that JavaScript has to offer, but also the most potentially confusing. And so we'll try to take our time through this. and see if we can work out the examples. I can't guarantee that this will be a smooth transition through every part of this, but we'll try our best. All right, so they create a function named makeAdder, and they pass in A. Then they return function B and return A plus B. And then they create a variable called add5, which is set equal to calling the makeAdder function while passing in 5. And then they set a variable add20, which is equal to calling the makeAdder function passing in 20. And then they call add5 with 6, and then they call add20 with 7, which, I mean, that seems a little bit confusing at first, because isn't add5 and add20 constants? Aren't they supposed to not be able to be set to anything? But remember that when the variable add5 and the variable add20 were set, they were set not equal to a permanent value, but they were set equal to a function. And passing in a variable or a number, a parameter inside that first function call, and then they're being called again with a number parameter or argument being passed in for that second function call. And it says that the name of the makeAdder function should give it away. It creates a new adder functions, each of which, when called with one argument, adds it to the argument that it was created with. What's happening here is pretty much the same as was happening with the inner functions earlier on. A function defined inside another function has access to the outer function's variables. The only difference here is that the outer function has returned, and hence common sense would seem to dictate that its local variables no longer exist. But they do still exist. Otherwise, the adder functions would be unable to work. What's more, there are two different copies of makeAdder's local variables, one in which a is 5 and the other one where a is 20. So the result of that function calls is as follows. Add5 with passed in 6 returns 11, where when the first add5 was set to makeAdder with 5, and then where it passes in 6, and then it returns 11 as the total. Add20, where its first one, add20, was set to makeAdder for 20, passes in makeAdder a 20 as a, and then returns with the function b and passes in something for b as well, which will return a plus b. And so b with 7 for the second one will set a as equal to 20, and then b equal to 7 for the second function call, and return the total of 27 then. Here's what's actually happening. Whenever JavaScript executes a function, a scope object is created to hold the local variables created within that function. It is initialized with any variables passed in as function parameters. This is similar to the global object that all global variables and functions live in, but with a couple of important differences. Firstly, a brand new scope object is created every time a function starts executing. And secondly, unlike the global object, which is accessible as this, and in browsers as window, these scope objects cannot be directly accessed from your JavaScript code. There is no mechanism for iterating over the properties of the current scope object. For example, so when makeAdder is called, a scope object is created with one property, a, which is the argument passed to the makeAdder function. makeAdder then returns a newly created function. Normally, JavaScript's garbage collector would clean up the scope object created for makeAdder at this point, but the returned function maintains a reference back to that scope object. As a result, the scope object will not be garbage collected until there are no more references to the function object that makeAdder returned. What's that saying is, as this first function returns another function, normally, any of the variables and things that are created inside this first function call would be garbage collected. But since the second function call is still referencing the first variable, a, then it's not garbage collected. It's not deleted. It's not removed. It still has reference to it. And so it's still allowed to exist until that second function call also returns. Scope objects form a chain called the scope chain, similar to the prototype chain used by JavaScript's object system. A closure is the combination of a function and the scope object in which it was created. Closures let you save state. As such, they can often be used in place of objects. You can find several excellent introductions to closures. Then they have a section with a asked, have you found a problem with this page? And you can edit on GitHub, source on GitHub, and report a problem with this content on GitHub. And that is the end of our video. Thank you so much for watching. I hope this has been a blessing and a benefit to you to go through a walkthrough of the reintroduction to JavaScript on the MDN website. And if you saw anything that you really have questions about that didn't make sense, I apologize if I did not walk through some of the code that in a way that made sense. And I hope I can do so better in the future. If you have recommendations, if you have questions, if you have suggestions or ideas that you want me to go through any parts or portions of any of the topics in this in a more detailed way with more examples, please let me know in the comments below. Thank you so much for watching. I hope you have a wonderful day.